Hi everyone, myself Dr. Manjunatha C, working as assistant professor in the Department of Chemistry, RV College of Engineering, Bangalore, India. In this video, I would like to discuss about one of the fascinating allotrope of carbon material, that is graphene, and its preparation by modified Amherst method. Graphene is a two-dimensional allotrope of carbon, which is a perfect atomic lattice in a single sheet. Means all the carbon atoms are arranged in the sheet-like structure, and this is the only carbon nanomaterial which is having only surface. Means if you look at that material in any direction, the top view or bottom view or side view, you will see only the one atom thick. Means only surface. That is the beauty of this material. This material was actually discovered by A.K. Game and Novoselov, the professors in Manchester University in 2004. And because of its excellent properties, electronic properties, and they received Nobel Prize for this material in 2010. This material has been found to be potential in electronic device community, especially in field transistor and electrode material. So this material is defined as it is an allotrope of carbon made up of single layer of carbon atoms that are bonded together in a repeating pattern of hexagons. And the beauty of this material, it is 1 million times thinner than the normal paper that we see. And it is the basic structural element of all the other forms of allotropes of carbon, the like charcoal, carbon nanotubes, fullerene. We can say that it's a mother of all the other forms of carbon. If it is rolled up in the form of tubes, you will get carbon nanotubes. If it is rolled up in the form of sphere, you will get fullerenes. Therefore, we call graphene as a mother of all the other forms. If you take 2-3 graphene sheet and if you rolled up in the form of cylindrical tube, you will get multi-watt carbon nanotube. If you take single sheet and if you rolled up in the form of cylinder, you will get single watt carbon nanotubes. And this is the two-dimensional graphene material, and it is having only surface made up of sp2 hybridized carbon atom. Okay, and this is the one-dimensional fullerene. Zero-dimensional fullerene, and this is one-dimensional single watt carbon nanotube, and this is one-dimensional multi-watt carbon nanotube. So this is the picture showing the two scientists, two professors, Andrew Gam and Novoselov, who discovered this graphene material in 2004, and for that discovery they got Nobel Prize in 2010. They are from University of Manchester. So if you want more information, you can get into their website. This is the website of Novoselov, Professor Novoselov and Andrew Gam. Okay, so this graphene is actually, after inventing this material and after receiving the Nobel Prize for this material, people across the world started preparing this by various methods. Of course, this material is Andrew Gam and Novoselov, they prepared by Scotch tape method. But people have invented various techniques to prepare this graphene material. So of course, there are two ways to prepare nanomaterials. One is a top-down approach, means you will have a graphite powder and take out one sheet from the graphite. That is one way of preparing graphene. And the other one is the bottom-up, means each atom, the carbon atom is arranged in two dimension on some substrate. It is grown from atom by atom, it is arranged by CVD method or epoxyl growth method. This is one way of preparing graphene sheet. Or the top-down approach, means by mechanical exfoliation or liquid phase exfoliation using graphite as a source. So these are the two ways of preparing this material: a bottom-up approach and a top-down approach. In the top-down approach, you will use graphite as a source of graphene, reactant precursor. This is the graphite. You will oxidize that. I will discuss in the next slide. The Ammer used, Professor Ammer, in the Ammer method, they used this top-down approach. In bottom-up approach, especially in chemical vapor deposition method, there will be a substrate, and by using a hydrocarbon source, they just deposit, they grow carbon atoms horizontally on the substrate, and then they will take out this graphene sheet from the substrate, and you will get graphene. But in this video, I'm more focusing on modified Amherst method. Okay, so in modified Amherst method, they use graphite as a source. We know that graphite is a three-dimensional material, and it is actually made up of millions of graphene sheets stacked one after another. So if you just take out one graphene sheet, you will get a graphene. Okay, our aim is to take out, separate all the layers of graphene in the graphite. Okay, what they will do is first, this is a non-polar in nature. It is not soluble in nature. First, they will oxidize. Means surface. Some of the surface atom is converted to carboxylic acid group by oxidation. So therefore, the first step is oxidation of graphite. So it involves in modify Mars method. The first step is oxidation of graphite. So graphite is subjected to oxidation. For that, they use KMnO4. KMnO4 in acidic medium acts as a oxidizing agent. Oxidizes the carbon atoms, not all the carbon atoms, some of the carbon atoms of the graphite. Okay. For that, they also add some inorganic salt so that it will separate the layers. The ions will go and sit inside the layers, and helps the KMnO4 to oxidize the graphite sheet. So this red color one, they're all formed epoxy groups or carboxylic acid groups. So this is graphitic oxide. We call it as a graphitic oxide. So then when this graphitic oxide solution is subjected to ultrasonication at high frequency, and they get separated. So we get graphene oxide. Graphitic oxide it looks like a graphite, but the surface is oxidized. After ultrasonication in water medium in polar solvent, they get separated. All the layers are separated, but each layer is having oxidized carbon atoms. Means it is rich in carboxylic acid groups and as well as epoxy groups. This is not graphene. So this is the second step, the ultrasonication. The third step is after getting a graphene oxide. We have to remove the oxygen in the oxygen which is present on the surface. So removal of oxygen is a reduction. So for that, we are using sodium borohydride or hydrazine. Using the strong reducing agent, all the oxygen atoms are being removed, and you will get a graphene sheet. You will get graphene sheet. So this modified Amherst method involves three steps. The first one is oxidation of graphite. You will get graphitic oxide. Then ultrasonication, you will get graphene oxide. All the layers get separated. Then it is subjected to reduction using sodium borohydride. You will get a graphene. The typical experimental procedure that you can adapt to prepare this material is as follows. So the first, you will take a graphite powder. You are converting that into graphitic oxide. First means oxidation. For that, you add sodium nitrate. Sodium nitrate salt is added so that the sodium and nitrate ions, they go and sit in between the layers, and helps to separate them in the solution medium. Then you add sulfuric acid and then KMnO4. KMnO4 in acidic medium acts as an oxidizing agent, and you have to maintain these conditions to room temperature because it's highly exothermic reaction. So you have to constantly stir and keep adding water. Then you should add H2O2 to enhance that oxidation reaction. Then you will get graphitic oxide. So then that graphitic oxide is filtered using deionized water and acid hydrochloric acid to remove any basic impurities, and it is filtered and by using centrifuge. Then it is subjected to ultrasonication. So it is after taking out the graphitic oxide in the water medium, it is ultrasonicated for 1 hour. So all the layers, graphitic layers, are getting separated, and you will get graphene oxide layers. So that is extracted by centrifuging that solution at room temperature. So then that graphene oxide solution is washed with deionized water several times. Then it is subjected to reduction reaction. This procedure involves two steps. The first one is oxidation, and then ultrasonication. Then in the second step, we are converting that graphene oxide into graphene. Means you need to remove oxygen from the graphene oxide, you will get graphene. For that you need to use some strong reducing agent. The graphene oxide solution is first dissolved in water. So then using hydrogen nitrate, slight reducing agent, and you need to reflex for about 80 for 1 hour at 80 degrees centigrade. Then you should add a strong reducing agent, that is sodium borohydrate. Slowly should add because it is highly explosive. Okay. So therefore, after adding sodium borohydrate, 1 milligrams of sodium borohydrate, you need to reflex that solution for for about 36 hours at 100 degrees centigrade. So then all the oxygen atoms of graphene oxide are uh, reacted with sodium borohydrate, and that graphene oxide is getting converted to graphene sheet. So then that graphene sheet is extracted by ultracentrifugation, then washed with deaerated water and dried at 60 degrees centigrade. So this is actual procedure that is to be followed in laboratory. Scale synthesis of this graphene oxide in Ammer's method using graphite as a reactant precursors. So this is about the graphene, the importance of graphene, and the detailed procedure that is modified Ammer's method used for the preparation of graphene from the graphite powder. This is, you can say that top-down approach, wet chemical synthesis method. Okay. If you have any questions or clarifications for watching this video, you can just contact me through this email ID. Thank you very much for watching. Thank you again.